Good day, class. You are welcome to my YouTube channel once again. I remain Adeyeye Adele Picture. So today we want to continue from where we stopped the other video. This density and upthrust part 2. All right. So we have some exercise on the board here for us to solve. And before I solve this exercise, I would like to throw more light on upthrust. I've already taught upthrust in my previous video, but I still have some other things to say on it so that you will be able to understand this exercise uh, as you are supposed to. So the other time I said upthrust depends on two things. Upthrust depends on number one, the density of fluid in which an object is immersed, and then number two, it also depends on the volume of the object which is immersed. Right? So that is why we have the formula upthrust on object equals to density of fluid, to show that upthrust depends on density, times volume of object immersed, then times G. So density of fluid and volume of object. Now, this formula is used when the whole volume of object is immersed. So we have only V. But what if a fractional part of the object is immersed in the fluid, say like half of the volume? So if half of the volume is immersed, it means upthrust on object is going to be equal to density of fluid now times half of the volume is going to be the total volume over 2, then times G. For example, if I have water in each of this container, if I have water up to this level and water up to this level. Now let me assume I put an object inside here partially. I dip an object here partially. What do you think will happen? There's going to be some displacement of water upward. There's going to be a displacement of water upward. Then if I now have the whole object immersed here, there'll be more displacement upward. So to show that upthrust depends on the volume of object that is immersed. All right. So the more the volume of object immersed, the more the upthrust on the object. All right. So that is upthrust for you. Now we can solve these problems on the board. So the first question says a block of material of volume 20 cm cube and density 2.5 gram per cm cube is suspended from a spring balance with the volume of the block immersed in water. Now, the volume of the block, the whole volume is immersed in water. This one is not a fractional part of the volume immersed, but the whole. So what is the reading of the spring balance? Now, the reading of the spring balance, they mean what the spring balance is going to read when the whole body is submerged or is immersed in water. So let's interpret what we have here. A block of material of volume. So volume of block is 20 cm cube. Then density of block is 2.5 grams per cm cube. Now it's suspended from a spring balance. Now, when you suspend it from a spring balance, if this is our spring balance, now suspend this block, suspend it, then you now immerse it in water. You immerse it in water. All right. Now, what the spring balance is going to read is not going to be the original mass or original weight of this block. What the spring balance is going to read will be less because of upthrust. There's upthrust. Water is going to exert an upthrust force on this, and then it's going to remove from the weight of the object. But what is the original weight, the original mass of the object? We have to calculate the original mass of the object. Then we also calculate the upthrust on the object. Then we remove the upthrust from the original mass to now know what the new reading on the spring balance is. All right. So density equals mass over volume. What's the density of the block? 2.5. What's the mass of the block? That's what we are looking for. Then we substitute the volume of the block, which is 20. M will now be equal to 2.5 times 20, which is 50 gram. All right, so this is the mass of the block when the block is not immersed in any fluid, when the block is suspended freely in the air. All right, so now we get the upthrust. But can we convert this one to weight? Weight is going to be 50 over 100, which is 0.5 Newton. Now let's get the upthrust on the block so that we can now get the reading, which is the new weight when the block is immersed in water. So upthrust on the block, because density of our fluid, now the fluid is water, then times volume of the block immersed times G. But this time around, I'm not using G. I'll be using 0.01 because density is in gram per cm cube and volume is in cm cube. So what's the density of water? Although we are not given, you should know that one offhand. The density of water is 1.0 gram per cm cube. I don't need to write the units. There's only writing the units. So 1.0 grams per cm cube, then times the volume of the block. The volume of the block immersed is 20, then times 0.01. Therefore, we are going to have 0.2 Newton. So that is the upthrust on the block. Now, what is the reading? The reading is going to be the original weight. Reading on the spring balance is the original weight minus upthrust, which is going to be equal to 0.5 minus 0.2, which is 0.3 Newton, which you can also convert to gram. So the mass is going to be equal to 0.3 times 100, and that's going to be 30 grams. So that's the reading. So meaning out of 50 gram, the original mass, what has left? 20 gram has left. So what the spring balance is able to capture is 30 gram. Water has already removed a mass of 20 grams. So we have 30 gram that is left on the spring balance, right? Then number two says a substance of density 5 gram per cm cube causes 50 grams of oil of density 800 gram per cm cube to overflow from a displacement vessel, right? So this is the density of the substance, and this is the mass of the oil. This is the density of the oil. Now, the mass of the oil that overflow is this. This is one that is displaced. So, density, let's interpret what we have there. Density of substance is equal to 5 grams per cm cube. Then the mass of oil displaced, mass of oil displaced is 50 grams. Now, the density of oil is 800 grams per cm cube. Now, the question is, what is the mass of the substance? Although we already know the density of the substance, so we have to find the mass of the substance. We can use the formula density is equal to mass over volume, but we don't know the volume. If you can know the volume, we just substitute both the volume and the density, then we make the mass the solid the formula, but the volume is not known. So, but from here, we know the mass of oil displaced. If we can get the volume of oil displaced, the volume of oil displaced is equivalent to the volume of the object that is what? That is immersed, according to what I did in the first video. When you immerse an object in a fluid, this object, what will happen? The volume is going to rise. The volume is going to rise. If before we had 10 cm cube, by the time this one enters, we may have something like 15 cm cube. All right, there's going to be displacement of the fluid, so that the volume of the fluid of the object that is immersed will now be equal to the volume of the fluid that is being displaced. Please go and check my first video. So we use density of oil equals mass of oil over volume of oil. So this is the mass of oil displaced, and this is density of oil, which is 800 equals mass 50 over volume of oil displaced. So volume will be equal to 50 over 800, and then the volume of oil displaced 50 over 800. That's 0.0625 cm cube. Now don't forget that this volume of oil displaced is equal to It's also equal to volume of object, of substance. Substance, we are using substance this time around. This volume of substance immersed. All right. Now, what are we asked to calculate? The mass of the substance. So we can use formula now. Density equals mass over volume. What's the density of the substance? 5. What's the mass of the substance? That's what we are looking for. Then what's the volume? 0.0625. Therefore, the mass of the substance, M, will be equal to 5 times 0.0625, which is equal to 0.3125 grams. So this is the answer for that. Then the last question says a body weighs 0.5 kg in air, 0.3 kg in water, and 0.2 kg in a liquid. So what is the relative density of the liquid? If you remember the formula I also gave in my first video, go and check part 1, the first video. The relative density of a liquid can be determined by using a solid. How? You first weigh that solid in air, so you know the mass of the solid you want to use to test the relative density of a liquid. Weigh the solid in air, you keep the mass. Then you immerse the solid in the liquid whose relative density you want to check. You immerse it in the liquid. There's going to be upthrust in the liquid. There will be upthrust on that object as a result of the liquid. All right. So then you now find the upthrust in that liquid. Then you also immerse that solid. Remove the solid again, immerse it in water. You also find the upthrust in water. So the relative density of the liquid is going to be equal to upthrust in liquid over upthrust in water. So weight, or let me say mass. This is not weight, mass. Mass of body in air is 0.5 kg. The mass of body in water, so it doesn't matter whether you immerse the body in water first or in liquid. So that's 0.2 kg. Then the mass of body in liquid is equal to 0. This is 0.3, 0.2 kg. So what is the relative density of the liquid? So relative density RD of liquid is upthrust in liquid over upthrust in water. So what's the upthrust in liquid? That's 0.5 minus 0.2, then over 0.5 minus upthrust in water, that's minus 0.3. So this is going to give me 0.3 over 0.2. So that is the relative density, 0.3 over 0.2. That's 1.5. So we have 1.5. And don't forget, there's no unit for relative density. All right. So I think I should give one more example. One more example. Don't let me take our time. Instead of giving the example, I think I should just give us this as an assignment. So we should take this one as an assignment. You can drop the answer in the comment section. So the question says, a body of mass 3 kg and volume 4 times 10 raised to the power of minus 4 meter cube is hung from a balance graduated in newtons. What is the reading of the balance when the body is question A now, in air, B, fully immersed in water, C, 1/3 immersed in water, D, fully immersed in paraffin. Now in brackets, we have some information here. Density of water is equal to 10 raised to the power of 3 kilogram per meter cube. Density of paraffin is equal to 800 kilogram per meter cube. So we should take this one as assignment. Thank you for watching. Please like, comment, share, and don't forget to subscribe.